So we're going to be talking about something called the 4Cs. These have to do with the essential skills that are being taught to help students acclimate to the current state of our society and of the world. And specifically, we're going to show some examples of how this might look in the context of a high school chemistry classroom. So basically, the question that we're asking is how can we change our education to meet the demands of what modern day society looks like, right? Because 50 years ago, it might have been really helpful to teach sewing skills or how to make cheese or how to make bread. But in our current society, these are not the most relevant things anymore. So we have to kind of reconsider what those skills are going to be that are going to help our students be prepared to enter the world and be successful in the world with the way that it is right now. So 4 21st century skills have been defined, and these are considered to be essential for modern students to succeed both in school and in the workplace in the 21st century. They include critical thinking, creativity, collaboration, and communication. So the first C, critical thinking, is a really nice quote. It's the practice of solving problems among other qualities. So the central question that we want to be asking as we teach critical thinking is what makes a claim true, right? So if somebody just kind of mentions, hey, I heard that climate change isn't real because it was super hot out in outside of my house yesterday, but 3 days ago it was freezing cold. So I don't think the Earth is really changing. So if we ask ourselves what makes a claim true, and we teach students to ask this question, and not only to ask the question, but then to answer the question, then we'll be teaching a skill called critical thinking. So in order to address this question of what makes a claim true, we need to start off by encouraging our students to assert skepticism. That means that when somebody makes a claim, when I make a claim as a teacher, when another student makes a claim, when a textbook makes a claim, we should say, this isn't some objective truth. There has to be reason, there has to be evidence, there has to be logic behind why this claim would make sense to begin with. And then from there, instead of just going along with the data that's given, we have to really ask ourselves, is this even the right data? Is this the right way of addressing this problem? Does this data really support the conclusion that's being drawn? And then we need to evaluate the data that we do have and ask ourselves, does it answer the question in the way that we want it to? So one example of a lesson that would teach this sort of critical thinking skills. So you could imagine that I, as a teacher, I tell my students that a particular element on the periodic table is more reactive than a different element. So they have both elements available in the lab, and I'm going to say, okay, so go ahead and test my claim. Go ahead and tell me whether my claim is true or not true. So then from there, the students have to say, okay, well, what does it even mean to be reactive? What's going to be a measurable, what's going to be some sort of measurable data that we can take? How are we going to evaluate reactivity? How are we going to set up this experiment? And then how are we going to evaluate the claim and determine whether or not it matches the hypothesis that our teacher gave us? So this would be an example of critical thinking. So you start with the claim, you ask yourself, what data do you need to evaluate the claim? And then you get the data and you evaluate the claim. So the next C that we're going to get to is called creativity. And the quote for this is, creativity is the practice of thinking outside the box. Okay, so we all can think of creativity in terms of music and movies and sports and making a beautiful painting or anything like that. But Creativity also applies to academic domains as well. Not that music and art are academic, but it could even be applied to something like a chemistry classroom, where you wouldn't really consider the role of creativity to be that valuable, but it can be very valuable, especially because um, you need to be able to consider things from multiple angles in order to gain new understandings and to further our knowledge of chemistry at all. So the question that we want to be asking and encouraging students to ask is, how can we come up with novel solutions to problems or challenges? Okay. And what we mean by that is, instead of just taking what's told to us as truth and objective truth, if we hear something and it doesn't really fully make sense, we should encourage our students to trust those instincts and say, hey, maybe it's possible that I don't fully understand what this idea is telling me, but it's also possible that maybe the idea doesn't really check out as much as it's supposed to. Maybe there's something that's contradictory about the idea. Maybe there's something that we're missing to the puzzle, something that needs to be added. The second part of this is integrating multiple perspectives. So what this means is being able to look at an idea or a system in a chemistry domain, and then considering it from a separate domain, something that's kind of unrelated, but can maybe help us to create a framework that will allow us to put these ideas into a new sort of format or picture, and maybe explain it in a way that we didn't really have the option to before. And that happens, all the time between when people will talk about how they only figured it out once they took some time away and they were thinking about they were trying to figure out some math problem, and they started doing a lot of physics instead because they were stuck. And then it was only once they started thinking about all of these physics ideas that the math problem finally made sense to them. So integrating multiple perspectives just means considering things from different angles. And then a very similar but final piece of that is coming up with new ways of doing things or understanding the system. So one example of a lesson that would help to build creativity. So imagine that you give a lesson on any core topic in chemistry. So for example, we're going over intermolecular forces right now. So let's imagine that you're discussing intermolecular forces. That means the forces between different molecules, what attracts molecules to each other, how do those strengths of the attractions change depending on what type of molecule you're looking at, what are the rules that govern those forces. So in order to build creativity, we might want to ask students to come up with a metaphor using an entirely different field, whether it be interpersonal things, or from a sports metaphor, or from biology, or just something that they encounter in their day-to-day life. They want to come up with a metaphor for how these things operate, and that's going to help them think about the concept from a bunch of different angles. It's going to help them create a better understanding of what intermolecular forces really look like and feel like and sound like, and it might even give us some additional explanatory value of what goes on in terms of intermolecular forces. So the next C is collaboration, and collaboration is the practice of working together to achieve a common goal. So the main question that I'm posing for this is, how can we encourage students to work together instead of competing against one another? Right? So the antithesis of collaboration is competition. So we can see other ideas and other viewpoints as being either better or worse than ours. So we might say, hey, I'm not somebody who has ideas of worth. My ideas are worth less than other people's. Or you might say, hey, other people's ideas are worth less than mine. And both of these mindsets are kind of the opposite of what we want to be doing. So what we want to be doing is asking, what do I bring to the table? So I have my own unique understanding, or my own perspectives. And then also, what do my classmates bring to the table? So they have their own unique perspectives and understanding. And using those to build to a greater understanding that you could ever hope to get to on your own. So the last piece of this that was not brought up in the article, but I think is really important, is called active listening. And this just means you're not just talking to talk, but you're not just waiting to talk, but you're actually actively listening when other people are speaking. You're attempting to take what they're saying, as importantly as what you're saying, and trying to fully make sense of that. So an example lesson that would build collaboration, you could group students into groups of 3s, and you give them a potential, you give them a phenomenon that we see in chemistry. So one interesting thing that I did recently was we burned different metals, and those metals, when they're burned, the flame is given off in different colors. So I asked students to try to figure out what's going on here. You can give them a little bit of a hint, a little bit of some background information to maybe help them get started. But the gist of the lesson would be that each student in the group comes up with their own explanation. And then from there, the students have to fully listen and understand their classmates' explanations, and they also have to fully share their own explanation. So they both have to collaborate in terms of bringing what they have to the table, but also valuing what other people bring to the table. And then they will list they'll identify the similarities and differences between their ideas and their group mates, and they will list the pros of each explanation. So for instance, they could ask, what is the evidence or the rationale that supports this explanation? Why is this a good explanation? Things like that. So this would really help to just build that sort of valuing the potential to work with others, and to try to actively incorporate everybody's ideas into the group. Even if they're not totally accepted, you could still learn from them. You could still use them to come to a more complete understanding a lot of the times. The final C is communication, and communication is the practice of conveying ideas quickly and clearly. So the central question we want to be asking as we teach this is, how can we transmit our ideas successfully? Okay. So of course I can sit and I can talk for hours. I can say whatever I want, but at the end of the day, if I can't say it in such a way that the person that's listening actually understands what it is I'm trying to say, then communication will not have been achieved, regardless of how long I've talked for, how many words I've said, how hard I've tried. It doesn't matter unless the communication is really there. That means that you have your speaker on the one hand and your listener on the other hand. It has to be a successful transmitting of the idea. So there's a few key points that were brought up in this article. The first is minimizing tangents. So this means keeping to the story that you want to be sharing, and not just going off in a bunch of different directions. You need a clear theme, you need a clear point, a clear message, and it's hard to understand what the message really is if there's actually no message, maybe, or if there's way too many messages that it's hard to figure out what the important one is. So you want to minimize your tangents. And then second, you want to speak directly to what you're trying to say. I have a problem with this sometimes. where if I want to make a point, I'll kind of talk about, like maybe I'll talk about how two things are connected, and I'll talk about these two things separately without ever explicitly mentioning that they're connected. And I'll just expect that the point is going to be made. But it's important to speak directly and think very clearly about what it is that you're trying to say, what it is that you have in your mind, you have some sort of understanding that works in your mind. And you need to figure out how to put that into words that actually make sense into somebody else that's not inside of your mind. So, and then finally, you want to check for engagement and understanding. So that just means stopping and asking occasionally, are you guys following? Does everything make sense? Does this specific piece make sense? I know I've been talking a lot for the past 10 minutes. What's the main point of what I've been trying to say? Things like that. So an example lesson that could build communication, again, you break students into groups of 3. They read and summarize an article to the group. So they have 2 tries to do a summary. So the first try, the listeners are going to make a note of every time they go on a tangent, every time there is indirect communication, and every time there is a check for understanding. They're going to give this feedback to the speaker, and then the speaker is going to try again. And the goal is not to be perfect, but it's just to, in the second try, it's to go on less tangents, do less instances of indirect communication, and increase the number of checks for understanding. And hopefully by the second or third time, they can improve their ability to communicate effectively. And then they can also see, and their classmates can share with them, hey, when you did this the second time, I really understood it a lot better. And they can get that immediate feedback for some specific measurable behaviors that they are changing. So in summary, we can ask, why do we care about these things? So from Stauffer 2021, critical thinking teaches students to question claims and seek truth. And this is especially relevant in our society today, as we have news sources and Facebook messages and a million different things that are considered to be true. And it's not always clear like who's right, who's giving us the true information versus who's just spinning their agenda. So we have to be able to evaluate specifically what they're telling us, what their claim is, and then determine the validity of it, and does their evidence actually support what they're saying. Creativity teaches students to think in a way that's unique to them. Okay, so it's definitely related to the last thing, to critical thinking, because students have to learn, and really individuals in a society have to learn to make their own mark on it. Not that they necessarily have to, but it enables them to function a lot better in the world if you can come to your own new ideas and bring your own creative solutions to the table. So you're going to have a lot more ability to be successful in whatever it is that you're doing. Collaboration teaches students that groups can create something bigger and better than you can on your own. So I really like the wording of this. And if you think about it, it's one of the main reasons that we're successful as a species is because we've been able to collaborate so successfully. We've been able to build these societies and organizations that can do so much more than any individual could ever dream of doing. And the same is always true. The more brain power and perspectives you can bring to the table, the better your final product is going to be. And then finally, communication teaches students how to efficiently communicate. Again, it's so important to, in order to collaborate with others and to understand what other people are telling us, that we have to learn into how to tell them what we think. We have to learn how to express our ideas clearly, get to the point, not be long and drawn out. As I sit here with my 20-minute lesson, not be too long and drawn out. But yeah, just get to the point and be clear about what we're trying to say. So on that note, I will end the lesson here. So thank you for watching.